Mic was off. Hello. I was like, why is it saying no signal? It always does that whenever the resolution changes. Anyways, hello. Let's see. I'm gonna have to switch over to this. Yep. So, chat. Welcome to our new lab setup. We have a so remember a few streams ago we inspected the NUC. So I've decided I'm gonna turn the NUC into a testing environment where we're not gonna run malware on it, of course, because it is still connected to my network, not under a quarantine network. But at least if we want to do anything experimental, we can do it on here. We're still going to run the malwares and whatnot in a Hyper-V environment, but, you know, today we're not dealing with malware, so all good. Okay, so, yeah, let's talk about what we're doing today. So, a few streams ago, I think it was the last REWorkshop session, we went through the infostealer Lazarus uses to dump browser information. And there was some interest in chat where they were like, can you tell us more about how infostealers work for browsers? So a few days ago, I finally decided, hey, since, you know, Chrome has its own app-bound encryption stuff, I figured now is a good time to make an updated video on this topic, because I'm sure a lot of videos that have already covered this topic have not covered the recent app-bound encryption stuff. So, yeah, we're gonna be writing video scripts today and figuring out how a few things work. Primarily, we want to look at how AB works today, and then revise our script. So I've already written an entire section on how base Chrome works prior to 127. Some of which needs revising, like here. A 3-byte magic, which is the character V. Hello, welcome chat. Followed by the that followed by 3-byte magic. That depends on the encryption scheme used, which for the case of DPAPI is usually V10. I suppose before I continue work on this, let's since you know it's gonna be quite some time before I put the video out. If you don't want spoilers of the video, you can skip this part. But I suppose I should quickly talk about how Chromium works prior to 127. It's something I'm going to talk about more in the video, but you know, if you're here for the script writing stream, I assume you're interested in the details as well. So let me turn down the music. I can barely hear myself. Okay, there we go. So, for all Chromium browsers, Chromium-based browsers, that includes Edge, Chrome, Opera GX, I'm not sure if that's a separate thing or if it's just part of Opera, and Yandex to some extent as well. I think Yandex uses its own stuff, not entirely sure. But yeah, for most Chromium-based browsers, they all use the same encryption scheme up until version 127, which was rolled out 2 months ago. Basically, prior to that, prior to a specific version, everything that you've ever interacted with and stored in your browser, so that includes cookies, login data, browser username, passwords, etc., etc. They're all stored locally and encrypted. So we're gonna later on in the script writing, after we're done with today's investigation, I'm gonna add stuff for Linux and Mac OS as well, but for now we're focusing on Windows. So let's start with how Windows works, Windows encryption scheme worked for Chrome. So for Chrome, let me pull up the source code actually, that would be easier to explain. Let's bring up DPAPI. When it loads, there we go. So, the way it works is that in Windows, there's a set of API called DPAPI, which stands for Windows Data Protection API. It's basically a newer version of an older crypto API, which you might be familiar with things like, I think it was Crypt Encrypt and etc. That's like basically a very legacy version of how crypto used to work on Windows. Yeah, the API is now deprecated. People should use Crypto NG, which is another set of things. DPAPI is just yet another crypto thing that you can use on Windows. And the way DPAPI works is that we're not going to go too much into details and into the rabbit hole that is DPAPI, but the gist of it is that if you want to encrypt something, you just call it something called crypt protect. And for example, where is it? Is it? Yeah, it's crypt protect data, right? Ah, crypt protect data. Oops. I should probably fix that. So the way it works is that developer only has to call something called protect data. And if we pull up a DPAPI in dev, there should be a slide from who is it again? I should have saved these links in my script. There's a PDF that went very much in depth on this. I should save that link when I find it. Was it this one? No, it's this one. Right. Let me save that real quick. So from the surface level, all a developer has to do is call crypt protect and crypt unprotect data to protect a data they want to protect, which sounds simple enough. That's great. And the underlying implementation from Windows basically goes through the trouble of using the user master key and or system master key, depending on what privilege you're executing it as, and then encrypting the data for you. And the user master key and whatnot, they're all encrypted with the user's password and a salt, which ends up generating a DPAPI blob for the person that called it, and then they could just take the secret and store it. And the way Chrome works is that whenever Let's go to app data. I think, no, it's local app data. Google Chrome. Whenever a DPAPI thing is first called, the key is stored under this local state file. Or rather, the encrypted key. It's stored under the local state file, which is basically a GJSON file. And it's stored under the OSCrypt as the encrypted key file. And this encrypted key is basically decrypted, and then the decrypted data is the DPAPI blob, which I believe the key is then used. Let me pull up my PLC. Sorry, it's been a while. So I wrote this PLC over the last few days, which is nothing special because most infostealer already write their own similar thing, just in a much better fashion. This is just a PLC after all. But yeah, you can see the way I wrote this is that, for example, if I want to get logging data, right, I would first get the OSCrypt data from here, which is gonna give you something. So for example, you set a breakpoint here. And you can see that if we check the loaded buffer, which is this thing that we just pulled out from, and if we do a basic C4 decode on that, you should see that it's a DPAPI encoded blob. And it's going to be prefixed with DPAPI. That's not something DPAPI does. That's something Chrome does. So you can actually see that in here where they add the key prefix. It's just more or less an identifier. So what we do is we strip that DPAPI stuff, and then we step up. And like this sounds fine in theory. Like, hey, you know, data protected using DPAPI is secure to the point where if you were to steal anything that's been encrypted DPAPI, and then you straight up just take the data onto another computer, it's not going to work, even if you have the key, because the user master key is protected using the user's password. And it's not as simple as just brute forcing it. Like, you can, but it's going to take some time to decrypt the user master key file. So what most infostealers do is, because of how simple it is to call DPAPI, what you do is, instead of trying to figure out how to decrypt it from the attacker's computer, what they do is, if they have ability to execute code on the victim's computer, which, you know, if you're effective in infostealer, of course they're gonna be able to execute code. What they do is they just take the data, yoink it, and then run crypt unprotect data on it, and bam, Windows is not gonna care who called it. It's just gonna be like, okay, I'm gonna use the user master key that I used to encrypt this, and I'm just gonna decrypt it for you locally. So, for example, if we again step back up, hello. Here we go, and then we step over. Okay, maybe not step over yet. Call crypt and protect. Okay. So we can see that the decoded encrypted key here, we pass it on to crypt and protect data, and it's just gonna be like, hey, cool, I decrypted the thing, and now you get to see what it looks like. And so now if we go step up, you can see that, hey, we can now have a decrypted master key. Step over. Why is the key? Okay. So the decrypted master key is then used to encrypt every single thing that you store in Chrome. So since we have the master key, why is it not? Oh, wait. Am I? Oh, that's right. I haven't stored anything in that Chrome yet. So let's go Chrome Dev instead. I have two versions of Chrome installed. One is Chrome, regular Chrome, the other is Chrome Developer Edition. So, I don't know why it didn't break there, but as you can see, when we call decrypt Chrome encrypted Chrome blob, we have the master key that we had obtained from decrypting the DPAPI key. And in Chrome, all of these data is then stored in a SQLite database. So for example, if I don't have SQLite browser installed. Well, let's install that real quick. What ID is this, by the way? This is PyCharm. I was going to use VS Codium for this, but it's fine. Okay, so let's now talk about where the encrypted data is stored. Depending on what you want, it is stored in different places. So for example, if I want to see what username and password I've stored, right, it will be under the user data, and it's going to be under the profile name, which could be default or profile followed by a number. And then it's going to be stored in, for example, login data. And now we can open this up with, since it is stored in a SQLite database, we can just use any database browser. It's usually under logins. And here you can see that, hey, we have a username password stored under this GitHub.io link. And the encrypted, the password is not going to be stored in plain text, of course. It is stored in this password value column as an encrypted blob. And anything that's encrypted with DPAPI will have a v10 prefix. So what we do is that now that we have the data, now we have the encrypted password, the way it works is that the 12 bytes following the v10, so like here to somewhere, is the nonce that is used for later on, and then the secrets is the bytes that follow it. And basically that master key is then used to do an AES encrypt, AEM, specifically AEM GCM, and then it is used to encrypt that secret. And we're not going to raise a value error for now. Let's just return none. And here you can see that, hey, everything that we just stored in there is now be able to be decrypted using this method. So that is basically everything that gets stored in Chrome, basically how it works. So that includes everything from cookies, username, password, credit card information, which, by the way, I didn't realize this until now, until like a few days ago. Apparently, Chrome now also stores CVC under specific conditions, which is kind of silly. I don't know why you would store the security code of your credit card locally, but yeah, that apparently that was implemented like sometime last year. It was just recently introduced, and some sealers are now yoinking that as well. I think it's stored under web data or something. Yeah, local stored CVC. It's odd that anyone would store credit card info in browsers. Yeah, people do that. Doesn't Google Pay not store security code? Does it? Should, yeah, but like, you know, that's under Google Pay. You have to authenticate for that to a remote location. But this one is just like, it's supposed to be stored locally. I tried it out. I could not get it to store, but apparently it was recently introduced where I couldn't replicate it. But under very specific conditions, I don't know what condition exactly, Chrome will ask if you want to save the CVC code. But if I try to do it now, it won't. So for example, if I open up, I use something called autofill smoke test. So for example, if I were to do this, let's try that. You can see that it doesn't store the CVC information. So I don't know what condition would cause it to save the CVC. Anyways, apparently it is now being stored. So for example, if I forgot which tweet I found it from. Let me see if I can even find it. Oh, oops. Replies. Where is it? I know I stored it somewhere. Hello, Torch. Oh yeah, here it is. This was implemented ages ago based on my search in the Chromium commits. This was apparently committed last June, but this was only recently introduced to the actual Chrome ship features. And there are already some info stealers that... Yeah, there is. There are already some info stealers out there that take this data. Again, I don't know how, and like for example, if you go according to this screenshot, if you go to autofills, it's gonna give you a bit. There's allegedly gonna be a field for you to enter your security code. But I tried. That is just straight up not available to me. I don't know under what condition that would show up. But yeah, that data is allegedly stored locally as well using the same method. So now let's talk about how Chrome now does it after 127. So Chrome recently introduced, by recently I mean like 2 months ago, it introduced something called app-bound encryption. So since the key is stored locally and anyone could just read the file and then call DPAPI to unprotected, what Google has done is instead of storing it in a file and storing it in a way that only requires user and master key to decrypt, what they've now done is that the key is now stored in an elevated service. So for example, if we look at how Chrome is set up now, we can see that Chrome now has an extra service. Now this has actually been around for a while, but it was used for recovery purposes, quote unquote. I couldn't tell what recovery purposes they were talking about, but this new service, quote unquote new, as elevation service, is now being used to provide encryption services for holding the keys. Now, the way it works is that Chrome now has to request the key from the elevated service, and it's going to check, hey, is it actually Chrome that's running? And if it is, then it'll decrypt the key, the master key, that using it's going to decrypt the master key using the system and user master key that DP API uses. And then it's gonna give you the key back, and it's gonna store the key, which is gonna be allegedly encrypted in memory, and then it's gonna use that to save or read or write encrypted data, which allegedly starts with cookies in 2024, so it doesn't currently protect anything else, allegedly. And that's the way they're proposing that it should work, so that this is actually a reasonably secure way of storing keys. Also, hello, Crispy. This was introduced back in Chrome 127. Now, of course, Google themselves acknowledged that this is not a perfect solution, because especially malware, any malware that can do ELP or elevation of privileges, it's going to be able to figure out a way to get the key. And the whole verify application as Chrome thing is also kind of dubious. It's like super easy to get around, because like all you gotta do is inject your code into a Chrome and should work. Because the way it works is that if you go in here, you're gonna be able to see there's an elevate service thing. Where is it? Elevation service, there we go. And yeah, it's all stored in this caller validation thing. I once again decided to take a nap. Decided a nap after work was a good idea. It was not. Yeah, I usually, when I wake up after a quote-unquote nap after work, I usually just go straight back into bed if it's like if I wake up too early. Anyway, so what we're trying to do today is, we're gonna have to try to explain this to viewers, the whole app-bound encryption thing to viewers. B, we're gonna see if there are any existing solutions out there that can get around this, because someone actually released a POC earlier today. This was by Snow v Crash. They released a POC on how they are able to get around this. We're gonna see how this works and figure out things from here. Oh yeah, so even before this public POC was available, like this was not available for the longest time, by the way. It took people 2 months to figure it out, I guess. But no, for the criminals, they actually figured out within weeks of this rolling out. People are very underground infostealers have already figured out how to get around this. So I think I closed it earlier already. But yeah, there are already infostealers out there that already claim that, hey, they can get around this without elevation as well. So that's what we're gonna do today. Before that, I'm gonna take a tiny little break. I need a restroom break real quick. I'll be right back. Alright, I'm back. Okay, so I want to take a look at this POC first. Also, this this POC actually included a very helpful resource that I did not see before. We're gonna get to that in a little bit. Hang on. Let's create a new window. Hello, Shane. ulc.cpp. Right. So what I did not realize is that apparently this was proposed ages ago. It's this PDF linked up here. Hello. Oh my god, a lot of people here today. Yeah, this was apparently proposed ages ago. This was proposed, I want to say before this date, because it says last modified. So even before, way before now, I guess Google has already realized that, hey, our current implementation is not great. Which is great, because we're gonna delve into what other browsers do, specifically Firefox does, after we're done with this whole thing. The way Firefox does it is even less secure. Unfortunately, like I'm a main Firefox user, and the way Firefox does it is pretty bad. Again, not the topic of today though. So I want to figure out what exactly they did here. So elevation service IDL. What the heck is an IDL? Interface definition language. Huh. Can you tell I don't do... Oh, it's for defining the COM interface, I think. Okay. Can you tell I don't do C++ very often? Okay, so... That's for defining the elevation service, I guess. Yeah, this was what originally the Chrome elevation service was intended for the recovery service. Huh? I'm not entirely sure what this CLSID elevator is. I know what a CLSID is, but I'm gonna look so dumb for people that are experienced with this. Yeah, no, so the co-initialize and co-create instance, all of this are basically used for doing anything COM related on Windows. Let's close all these other stuff. It's right here. Hello, hello. It's referring to line 140. Oh, that is not what I meant. Encrypt app browse. Yeah, string. Oh yeah, by the way, so before I couldn't figure out why my Chrome was not consistently using ABE for storing secrets. I figured out if I were to use something called Chrome profiling or something. I don't remember. Let me bring up my... Also, thank God for this Nether instance still working. Because I thought most Nether instances have already died. This is one of the few ones that still work, apparently. So I thought I was supposed to like turn this service on manually, but I've heard from a bunch of other people that are more expert on this topic and tell me I shouldn't have to do that myself. Oh yeah, it's this thing. So apparently this thing should tell me like what these things are reporting, which should help me figure out if it's using AV or not. Anyways, I believe one of the things it checks if if it's gonna use APE is something called support level. No, which one is it? Like there was that one thing that checks if it's supported. Oh wait, no, I think I linked in the tweet actually. It was this. It's in line with 152. Is it this one? Oh yeah, this one. Ooh, that's where there's the whole histogram thing. Okay. Anyways. Remind me, how does code create instance work? I'm gonna look very, very dumb. That was WRL client.h. Oh, apparently that is the thing. Okay. I think it might help if we open up this in Visual Studio, actually. Continue without code. New project from existing code. No, we don't want Copilot. Get out of here. Man, this poor CPU is dying. Yep. It's dying. How's that defined by? W type space. Ooh, okay. IID elevator. So that's that. I still know what this is. What these are. Open that up again. Nope, not C. C++. Thank you. Huh. So if we want to work on Chrome dev, I guess we have to use this. Just to make it a little bit more readable. I mean 2 minute initializer value. Oh. Oops. There we go. And the IID elevator. That'll be that. Yeah, it's the elevator service. App-bound encrypted key, so it's expecting us to store the key that we obtained from local state here, I guess. Not C++, JSON format. I'll just hard code it for now. Retrieve encrypted key. APPB. Let's just hard code that for now. Oop, that is not what I meant. Let's close Chrome Dev real quick. I want to step through this to see if this works. Uh-huh. 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 The encryption failed. Why is that? 203, that doesn't really tell me anything. To encrypt data. Oh wait, not you. You. So yeah, the elevator server still uses DP API underneath. It's just using the system master key. What the heck is 203 though? Cert util. What's 203 in text? Or can I just type 203? The system could not find the... What? Huh? Is that it? No, that's under HTTP. No, I think that's it. Also, I think it's whenever you decrypt data through the elevator service, I think it creates an event log entry. I think. Let's check. Sorry, where is that? It's under 257 in the Chrome source. Where's the Chrome source? Unless it's under application. Oh, failed to authenticate caller process. Ooh. Right. Because we're not Chrome. Yeah, that makes sense. 154. Caller validation. Generate path validation data. Huh? Oh. Get process executable path. I mean, can't we get around this by injecting this into, like, Chrome? Right? Okay, I might have an idea as to how I might make this work, but I'm also not entirely sure how I'm gonna write it, because I've barely written C++ before. So I guess I can compile it and then try to inject it into the Chrome process. Okay, that's gonna be a thing. I'm gonna need another bathroom break. I'll be right back. Oh, this is gonna be a dookie to do. Alright, I'm back. Okay, I guess instead of writing this, we can... Instead of echoing this out, I want to do... Oh god, I'm gonna look so stupid. How do I do this? Let's ask ChatGPT. Hi, write me something that takes an input path and a string so that I can log file, log message to a file in C++ on Windows. Create content calendar for TikTok. Yeah, I don't know why that's one of the options. That sounds horrifying. Yeah, let's just plop that in there. Hope that works. That I was gonna say that makes sense. Does this make sense? I've never seen it written like this. Huh. Okay. Well, I'll take your word for it. No, actually, discard the file path. Make it write to log.txt or something. Sure, let's do that. I'm so fucking stupid when it comes to C++, dude. Oh my god! Look away if you do this for a living. Does that work? I sure hope it does. Oh, hello. Thank you for the follow, Scamish. Once again, look away if you know what you're doing, because I don't. It just occurred to me. I should probably make an add. Oh, it does add an end line. Okay, that should be fine then, I think. Oh, nope, that's out. No, do not hot recompile, thank you. It's gonna be so jank. I hate this. Oh. Alright, let's see if that works. It kinda worked. It didn't. Okay, let's see what went wrong here. What is going on? We are doing some very jank things. Why can't I do something like this? How come that doesn't work? I might be stupid. Because it didn't put the message in there, did it? Am I missing something here? Can you cast this? Like this? Does that work? I don't think it will. We'll see. Nope, that's still nothing. What? Why is it not logging? Slightly enhanced error checking mechanism. Sorry, what did you add? Because it doesn't look like you changed anything. Huh? Okay, what if I would do that? Oh. Oh, it's because of the plus. Okay. Okay, I can't just like plus. I can't concat string like that, huh? Concat string. Yeah, that should work. Does that work? If I were to just cast it as a char? What? What do you mean encrypt the key? Huh? Okay. Plan B. Instead of doing that, how about we do this? Right, we need to... That works. Okay. If you say so. Okay, no error. Huh. Okay, that It's looking a little janky for the time, but that works, I guess. Sure. You know what? We'll take all the W's we can get around here, as the kids say, or something. Okay, so let's pretend we're Chrome or something. Release. We're not gonna worry about injecting for now. Let's pretend we're Chrome. Let's go to chrome.exe. Yeah, it's easier if we just do this. Yeah. Yep. Dead Chrome back. Okay, that worked. Sure. Okay. Now, it's of course not ideal because we were gonna have to replace Chrome with that, which is not ideal. So let's see if we can, I don't know, inject this into Chrome or something. I don't want to write C++ code. We should be able to do this with just Python. What? Why is it doing all of this? We know that's not what we're looking for. Into running Python processes. Wait, no, that's not what we want. Share the library. I think that's more or less for Linux. Can't we just like virtual lock ex resume thread, create thread and then resume thread on it? No, get out of here. Oh, we don't need shellcode. Thank you. Now, WMI is a horrible way to do this, but sure. I don't like people that just calls WMI with Python. But whatever, it's fine. I just want to see if this works. Oh. What? What? Oh. Mem commit is not defined. Let's do this. Well, Chrome crashed. Didn't like that. Yeah, I didn't like that. Okay. I'm not surprised. I didn't expect that to work. Give me a second. Sorry, I've had too much tea before a stream. Okay. Okay. Plan B, we turn that into shellcode. Hazard should have something for us. Yeah, of course. She always does. Thank you, malware lady. She's so good at what she does. Me POC.exe. Oh, we don't have 010 installed. Let's install IMHex instead. Oh god, that thing is huge. Let's install Area 2 first. Okay. You're currently watching probably the most idiotic part of the stream. I would not be surprised or mad if anyone comes in here and be like, what the fuck are you doing? I'm not very familiar with how this all actually works. I'm only good at reversing, not so much actually writing malware. Like, I'm very familiar with all theoreticals, you know. There's a reason why I'm on the blue side, not the red side, because I suck at this. Okay, I just want to double check if this thing is in shellcode form now. Hello? What? Oh, there it is. Hello, can you open this for me? Thank you. No, I don't care. Yeah. It's fine. No. Done this already. Okay, well, let's see if that works. We should probably add a new argument. Targets P. Target P. Nope, that just crashed. Why is it crashing? We might also have to install x64 debugger so we can figure out what's going on. Do PID instead. So we know who we're injecting into. Okay, so let's inject into that. Before we do that, let's release that. So we can see why exactly it's crashing. If I were to guess, it's because it's trying to write into the Chrome folder. And that thing is ACO protected. Oh, wait. Yeah. Run as admin. Because you want to do... We want to register ourselves first. Preferences. JIT debugger. So now we can do this. Okay. So if I were to... Don't break on TLS, thank you. Ignore last. No, not ignore last. Don't... TLS callbacks. There we go. Ignore last. Thank you. Okay. Let's see why it... Stop! I don't care. Do not break. No, actually, we need to break. Not this, though. Yeah. Do not break. Do not break. Do not break. Thank you. Int. Nothing happened. Why is that? Oh, wait. Because FPID doesn't exist. Right. What? That still doesn't work. Also, why is it running as admin? Okay, fine. Let's try this random. I'm not that familiar with ABE. It sounds like Chrome is running a system-level keychain or something. Yeah, so here, let's do a quick rundown again. So the way ABE works is that instead of using the user master key for DP-API encryption, what it now does is that it does all that in the elevated service instead. And in that case, it'll also have to use the system master key. You can see the actual implementation in here. Yeah, the elevator.cc place, file, source code. Basically this graph. Why is it not working? Okay, let's detach. It's attached to this. Well, try that again. Nothing happened. Can you print out the memory address, please? Okay, well, hex. Thank you. Yeah, a thread was created. How come that didn't work then? Ooh. Okay, that's bad. Oh, that's just... yeah. Okay, that makes sense. That crashed, that's okay. We'll pick another victim. Okay, so I actually want you to breakpoint here. Or actually, we can just do input. Yeah, like that. Breakpoint here. We're gonna see if it tries to do what we're expecting it to do first. Actually, before we do that, I want to check the event log. Okay, nothing too interesting here. We haven't tripped the path validation yet. Where's Visual Studio? There you are. Breakpoint on co-initialize X. It didn't even trigger that. What the heck? It's just straight up exiting. Why is that? No, that's all we're looking for. I don't have IDA installed on this machine, unfortunately. Which is going to make this a little bit annoying to do. But I do want to check. What's the shellcode you're trying to inject in this case do? So it's this PLC that was written by Novi Crash, where it retrieves, where it tries to communicate with the elevation service directly and obtain the master key from there. Now, of course, the PLC doesn't really take into account that's not running under Chrome. So if we go back to our little graph here, you can see that the elevation service actually does check for the path of the caller, which should be easy to get around if we were to inject into Chrome, because all it does is checks the caller path, caller validation here, where it's just, yeah, this. Don't know why the P is not working though. Like we know our PLC works, or at least not mine. That their PLC works. I just gotta figure out why my injection is not doing its thing. Actually, let's step through this again. AB is to protect against infostealer, but not process following injecting code. So AB works. The problem is the way it currently validates whoever's calling it. Right? It doesn't. All it cares if it's coming from Chrome, and if it's doing the proper thing required. Yeah. And I have to assume injecting as Chrome works. Because if, for example, if we were to run this outside of the Chrome directory, we're gonna get an event log ID that just says, "Hey, failed to call authentic caller process." But if we were to run this as Chrome, for example, if I were to remove this Chrome.exe with our thing, then it actually works. So we know that all the hang-up is on the caller authentication, basically. Caller validation. And yeah, it just sounds like... I don't know. I don't see anything that checks. Like, this looks fairly normal to me. Like... there's nothing here that would detect if it's coming from injected code, because it just checks if the caller process is Chrome, I think, unless I missed something. Anyways, that's not the problem at the moment. The problem is our thing is not running to where I expect it to. Okay, so This is gonna be really... This part is gonna be really annoying to look at without IDA. I think this is just CRT doing this thing. Oh wait, that's a P loader part. I can tell that without looking in, because 5A404550. Oh, that's just returning to what? Hang on. Let's double check our converter shellcode actually works, because we didn't actually test that. Let's try this. Is there an event log ID? Yeah, there is. So that should run. Don't know why it's failing in Chrome. Or inside the injector process. Let's see, what does this injector do? Okay. So this should do the same thing as our Python code. Let's inject that into, oh, I don't know, 8716. Wait. No. Let's delete these. No, that didn't work. Why is that? Let's also check how the injector works here. Yeah, it's just a simple career mode thread. I don't see why that wouldn't work then. What? Okay, if we can't get it to work, that's fine, because we already know that the POC works. We don't really need to worry about the... We don't really need to get it to work to that degree, you know? But, I'm just wondering why that didn't work. Because, like, for example, if we're expecting it to at least call co-initialize X. It didn't do that. Like, BP, yep. Doesn't do its thing, it just exits. Oh well. I think I'm gonna give up on that. That's fine, because, like, we already know that definitely works. But, or at least it does return something. We'll know if the return key actually works. Let's just assume that we're running the code as Chrome. Yeah, it does spit out a key here. But does this key work as expected? That's the thing. Okay, there we go. So let's just put our hardcode key in here for now. Bin ASCII and hexify. This music slaps, by the way. So true. It's from Sonic Mania Plus. And hex key. So I wonder if it works the same way. Is this still using AES? No? Like it did decrypt, but that's clearly nonsense. Wait, does this key change every time? No, it doesn't. Where is it getting this? Here? Okay, so it's reading from a google.com entry. Let's see, encrypt data. Not you, you. AES 256 GCM. Wait, how big is the key that we just got is? Unhexed key lang. Wait, what? Ooh. Oh. Oops. Oh, no wonder it didn't work. Yeah, that makes sense. I think it should be this. Right? And then we try... No? How big is the unhexed key? 16 byte. That sure feels like an AES key to me. Ah. Master key is supposed to be 32 bytes. Why is this a 32 bytes? 16 bytes then? Huh? Unless this doesn't need to be unhexified. Hang on. No. Yeah, we'll make that bytes. We'll do that. B. Decrypt secrets. No? That's still gibberish. What? Okay, I want to compare this to the DPAPI implementation. Who's calling get key internal? And who's calling get key? Oh, my brain hurts. Nope, nope. Why is this 16 byte key? Is this supposed to be 16 byte? Gotta run, have a good stream. Alright, see you later. Thanks for stopping by. Have a good night. Yeah. I also wonder if I can re-implement this in Python. It's possible, right? It should be. Okay, anyways, I want to double check if this encrypted key is correct. Did I copy the wrong key? Is that why it hasn't worked? Hang on. Okay. No, that seems correct. What? Wait. Wait, what? What do you mean not found? Oh, do I have to paste this up? Okay. I think it's top to bottom. That's why it didn't work. Yeah, it's top to bottom. But didn't I put something else in there before? Okay, what if I were to put this in there? Encrypt failed. Oh wait, because that's... yeah, that's not the right thing, of course. Okay, I'm not sure if I understand. Why is this 16 byte and why is this not working? Because it's still using AES. And unless they change how it works, how the actual alias part works, which is entirely possible, but oh, my brain hurts. No, not you. V20. Right. App-bound data prefix. Yeah, it should be 32 bytes. Why is this 16 bytes then? What? Huh? Wait, what? No. Call stack. Okay, here. Ciphertext, plain text. Ciphertext. Oh, that's not what I meant. Plain text. Sysstring lang. What? Yeah. What? So this should be where it calls decrypt data. We're passing That's where last error should be. And this is ciphertext, plain text. I don't see anything changed in what? Huh? What format is BSTR? Remind me, what does a BSTR structure looks like? No, BSTR. Okay, hang on a second. I'll be right back again. There we go. Okay, I'm back with a scone. I love scones. I needed that tea very much. I'm about run out of tea. Man, having IDA would help a little bit right now. I should install IDA on this after a stream. Not now, though. When does a string get created? Like here. CD 36, okay. Is it perhaps not? Am I wrong in assuming that this should be an RTX, RDX, and an R8? It's like none of these values make sense. Okay, I'm gonna make this a little bit easier on myself and open IDA, which I don't have right now, but I can copy this to my main computer at the very least. Okay, let me switch over to my main computer. Oh, there we go. Okay. Here we go. Isn't commonly downloaded. Yeah, I know it's probably a malware. It's alright, I wrote this. Or I didn't write this, I compiled this. Okay. Okay, it's kind of annoying that I can't see my main monitor. I'm gonna switch back real quick. It might lag a little bit. Nope, it did. Okay. Okay. Oh, hello, thank you for follow. Referee. I assume that's how it's pronounced. Okay. Let's see. Okay, I have the IDA thing open right next to me. You guys can't see it because it's my main computer. Okay, there we go. Oh. Wait, what? Huh? So it's actually an R8. In IDA, it says there are 4 parameters. As opposed to 3. Okay, I don't understand C++. But that's okay. Sure, well, I'll take your word for it. So I guess it's on R8 then? Okay. Wait, what? That's not what the cryptic key is supposed to look like. Or at least not the one we got. That looks like it makes a little bit more sense. 32 bytes. Okay. Cyber Chef. Hello, welcome chat. Okay, so from hex dump to hex. No space. So I think that's what the key is supposed to look like. I don't know why our key ended up being really weird. Okay, so that makes a little bit more sense. Let's try that. Okay. Ah! What? Uh-huh. Uh-huh. What? Huh? What? How come the output here is like different from the output? What? Wait. Let's try this. Try this again. Because I want to say it worked, but not quite. Because we're getting something readable here, even though it's still in gibberish. Wait. Which cookie is this? Step up. No, step up. Oh, oh my god. Don't decode. Not serializable. Yeah, that's fine. That's fine. Hang on. Night mode 2. Personalization ID V1 for V1. Okay, so it worked. Okay. It's just not quite what we're expecting. Okay. Oh, wait. Here we go. So it's not counting backwards from minus 16 anymore. It starts from 32. Okay. Oh, right, I should probably exit out of Chrome. Oops. Unknown prefix value. What? That's not unknown. That's V10. Huh? Oh. Oops. Okay. How do you return a tuple type in Python again? Type hint. Ah, lowercase. Okay. Why is there a squiggly line? Oh. Okay. Run that again. Okay. We figured it out. So, there should be some value that should be false, right? No? Oh, wait. Yeah, it's gonna be assigned anyways. Okay, let's try that again. So if we do that, Okay, we can see the cookie values are all encrypted using ABE. We can validate that by checking the SQLite thing here. We check cookies. And Chrome dev. Check the encrypted value. Yeah, they're in v20. Okay. Okay, I'd say job well done then. Then let's move on to getting back to actually writing the script here. This doesn't sound very secure, doesn't it? The Chromium team is way ahead of you. Is formerly Chrome Elevated Data Service. I want to see when this was drafted. What do you mean no results found? Oh my god. Okay, this is not searchable, apparently. That's lame. No, get rid of Australia, thank you. I couldn't find details on when exactly. When was this implemented? Let's go to the Chromium source code real quick. Let's check the history. A draft for something called app-bound encryption. Formerly known as Chrome Elevated Data Service. This feature was then rolled out in July of 2024. First announced in a blog post from Google titled Improving Security. Here we go. Let's take a look at the graph linked in the it should be using just the system master key, right? Oh, I just realized I haven't been able to see the YouTube chat until now. Oops. How does it validate the path again? Get calling process. Where's get calling process? Caller validation. Okay, so it's normalized to... Wait. So can I just... Hang on. Can I just do this? Oh. That'll still work. Hang on a second. Right back again. Okay. Okay, I'm back. So, I don't even need to call it as chrome.exe. We just be it can just be anything under the Google Chrome dev directory. Because it also strips out the word application. $257. What is it called? Chrome dev. Application. What? Why is the message empty? Data? No, not data. Log? What? Okay, let's do FL. No, sorry, FL star. Replace. Wait, what? Why is it called replacement strings? Ah, whatever. What's a time thing called? Time written. While true. Is there a way I can like stream event log data? That'll do too. Sure, whatever. Oop. There we go. We'll copy this to split down. Oh, wait, no, here. So... okay, that still works. Is there any directory here that's user writable? ICACLS. The application data is writable, but not for everyone, I think. Let's start. Okay, let's. Yeah, that's not writable. That's also not writable. I'm not surprised. Okay, well, it's not my job to see if there is any way around this. I'm just here to report the facts. So... was it 237, 257? Man, this is gonna be a pain to edit when I get to the editing phase. What's the full name of ACO again? Access control list, that's it. Yeah, that's it. Let's just say file permissions, that's a little bit more simple. Wait. Can I just do a process hollowing instead? Like, all it checks is if it's under the Chrome dev directory, so like we could use any of the exes in here. So technically if we, like for example, we'd start Chrome proxy and then process hollow our POC in there, that should work as well. Okay, so originally I was going to cover Mac OS and Linux as well, but I feel like it's very outside of the scope now. Because, like, I don't know how I'm gonna... It doesn't flow quite right. Because we're starting with Chrome, and then Chrome 127. And both of these were covering Windows specifically. I suppose... I mean... Chromium, Linux, macOS. Yeah, okay. I mean, that still makes sense. So we're just covering... Because Chrome is not... Like, 127 plus onwards is not affected. Or rather, AB is not part of Linux and macOS. So putting that after these two should still work, yeah. I want to talk about Firefox, though. I'll investigate this after... at some point. This video is getting out of hand. Oh my god. There's so much research. Is Waterfox still a thing? Let's check our trusty... Hang on, let me save this tweet first. Let's check our trusty Arch Wiki Linux. I mean, Arch... wiki.archlinux.org. Firefox. Gecko based. Here we go. What the heck is Sea Monkey? Oh, that's like the original Firefox. But like, continued by others. What the hell is Fire Dragon? Yeah, I guess Waterfox is still a thing. Do I have Firefox installed? I don't. Well, let's do that real quick. Because I want to do the test on vanilla Firefox first before we do Liberty Wolf. We've been streaming for 3.5 hours. Whew. I'm a little tired, honestly. It's only 1:25 though, p.m. I'm gonna check my phone real quick. My notification keeps popping off. Uh-huh. I kind of want to revisit the POC off stream because I feel like that's a lot of work to do on stream, but I kind of want to re-implement this in Python. Not now though. Alright. Oh, fill smoke test. Is that the only thing on autofills? Just passwords? Huh. Okay. Save. Okay. So if I remember correctly, okay, we don't need to remember this correctly, actually. We can just do, hack browser data. Is that what it's called? Yeah, that's what it's called. There are so many open source infostealer we can take a look at from. Oh. Okay. Code hack. No, I think it's Codium. So if I remember correctly, it's basically just yoinking the master key from key4.db. And let's create a new thing. PLC Firefox, PY. We'll just copy this. Import pathlib, import os, key4.db. It's under app data. Mozilla Firefox profiles. Did we do a glob in here, perhaps? Yeah, we did. Key. Well. Get key DBs. List. SDR. No, let's do path. For Firefox profile in Firefox profiles .rglob. Key4.db. Nope, no, wrong thing. Okay. So, if I remember correctly, it's just another SQLite database. It's in somewhere. Metadata, password. Okay, I don't really know what I want to do in this function yet, so I guess just do that. With hey man, how are you doing? Good topic, Dora. And unfortunately for me, it's 1:30 a.m., so I may not stay on for long. That's okay. Understandable. What does connect take again? I keep forgetting how the SQLite 3 library works on Python. Does it need to socket? What needs a socket? It shouldn't. Oh yeah, we're past the Chrome AB stuff, by the way. We're moving on to Firefox, which should be easy. Yeah, we're connecting to Firefox. For C and cursor. So C0 should be IM1. Yoink that from, this is private. Do that again, but A11 C0 A102 from C1. I kind of forgot this. Okay, I'm gonna check for a Python implementation of this instead. It would be easier if I had access to okay, I'm gonna use my main PC's GitHub instead. So let's do soak A11 language Python. Ah, right. Our favorite, lasagne. thing everyone loves to use. I forgot about this one. Yep, that'll do. Right, now I remember, it's using 3DS. Oh my god, it's so much inferior from Chrome. Oh god. Yeah, I mean, like with Chrome, at least if you take the DPAPI blob to another computer, you can't just decrypt it, you know. But on Firefox, all you gotta do is just yoink the key for DB, and that's it. Right. POASN1. I think I might need to install the package. Yeah, POASN1. So we went through this earlier. We went through how Chrome's password secret storage works. On Chrome, prior to 127, you at least have DPAPI that encrypts your secrets, which if you're familiar with DPAPI, how DPAPI works is that anything that's been encrypted with DPAPI, you can't really decrypt it unless you are on the machine that encrypted it, because it uses the user user master key to encrypt it, and unless you also steal the user master key, and then you also go through trouble with breaking the hash of it. Otherwise, you can't really decrypt it on another machine or an offline attack. But most people get around it by simply calling decrypt locally on the victim machine instead, because you can call crypt unprotect data on locally on the victim's machine, and DPAPI will happily spit back the decrypted data. In Chrome 127 and above, they moved all of that to something called app-bound encryption, where the master key is generated and then encrypted by an elevated service, and this elevated service is then responsible for decrypting the key whenever Chrome wants to encrypt something. And whenever Chrome wants to encrypt something, so it'll have to take the app-bound encrypted key that was first generated and store it in the local state file. Yeah, Chrome, VS Codium, that's it. Whenever Chrome wants to encrypt something, it'll have to take this key and send it off to the elevated service. Then the elevated service will decrypt the key for Chrome, and then that key is then used to encrypt all the secrets that it needs. What app is that? What app is what? Which one? The one that you found, the local state, this thing? This is everything. It's a very good app. It's from Void Tools. Everything is basically I would say the search engine to use on Windows, because it works super fast. Since the way it works is that it parses through the MFT table on your NTFS drives, and then it caches it. So that means whenever there's a thing that gets changed on your disk, it immediately knows, and searching anything is just way easier in here. Anyways, yeah, Chrome is a lot more complicated than how Firefox does it. It's also very useful when you're like for example when you're doing malware analysis, right? And when you want to check what got written to the disk, you can just sort by date modified. And if the thing also changes the date modified attribute, you can at least do like date created. Or obviously that won't always work if it changes the date modified and date created, but usually I see a lot of malware devs only change the date modified to something more benign, but they forget to change date created sometimes. But yeah, anyways, it's helpful in those scenarios as well. Anyways, let's get back here. Okay, I've installed that. So now we do decoder. Decode, I think it's A11. Yeah, A11. Surely there is a helper library that does 3DS for us, right? Do you think Maldoc has it? Man, it was one heavy package. Oh, moment of truth. Does it have it? Crypto DS3. Okay. Okay. So I think it uses CBC, right? Manage master pass. Oh. Wait. Oh, Lord. Wow, this is a very messy way of writing this. Surely there's a better implementation that I can copy from. That looks ever so slightly more promising. Let's see. Ooh, this is from 2013, and I don't know if Key4DB has made any more changes. Let's see. Okay, that looks slightly better. Okay, I'm also pretty sure they just yoinked this from somewhere. Let's see. Only self. Hello? Autocomplete? Hello? Key IV data. Is it also expecting key IV data? Screw it. Fine. We'll copy this. It's starting to get out of hand. Yeah, master password by default should be empty. Hashlib. Import the ES3. Of course, it's Cryptodome again, our favorite library. Import HMAC. Okay. Just C0, C1. Oh wait, what? Oops. Wasn't there a way to dict object? Give me Python docs, not all these other crappy sites. Thank you. No, that's not what I'm looking for. Dictionaries. Ah, equals. Right. Yep, that's what I was looking for. Is A102 even used? Ah, it's just used to validate if that equals that. Okay, let's see if that works. I don't expect it to. Yeah, it doesn't. Alright. Master password is not L. Right. I think we could just give it a none. Because as far as I know, there's no master password needed. No, not you. Get out of here. Oh, hang on a second. I'll be right back. I need a tiny little break. think I meant to do this instead. Why is this so needlessly complicated? Why is it written like this? That should work, no? No. Well, it did return a key. Now the question is that key correct? Hey, Rock. What's cooking? Firefox, apparently. I should just return the key, I think. Get login. Where the fuck is get login data? I don't want to sign in. Let's see. So it's sign on. Wait, sign on. What? Logins.json. Okay. Oh wait, I forgot to. Okay, let's try that again. Okay, so load the JSON. Logins. Type. That's a list. For login and loaded JSON logins. Breakpoint. Login. Encrypted username. Can I turn on word wrapping here? No? That sucks. Alright, so we've done Chrome? Yeah, I've already done Chrome. We spent like the first 3 hours on it. Where was I again? Here. Decode login data. What? Uh-huh. We're doing all sorts of copy pasting today. Oh my god. What? What do you mean it's just username's second value? What? Huh? Hang on. Okay. Not a valid triple DS key. Well, what's the key length of a triple DS key? Because we did get a 32-byte key out of that. But that key value looks a little weird. Why is it suffixed with 8 0x08? Sorry, 0x8. What? Huh? Chat, my brain hurts. I'm hungry as well. Kind of curious. Because I might not bother writing my POC. Oh, I'm glad I have Defender disabled on this computer. You didn't hear that if you're a threat actor. The reason why I say I'm glad it's disabled because I'm in packet triggers Defender. If you try to install in packet with PIP, it's gonna go off. Be like, what the hell are you doing? That's a lot of package. Oh my god. Sheesh. Okay. Collect. No target loaded. Let's see, Firefox. I'm a little sleep deprived now. Slower reaction time. Why is it? What do you mean key error? Yeah, Firefox is there. Unless I'm expected to have like uppercase. Kinda. So this thing is complaining about char map a lot. No target loaded. What do you mean no target loaded? Oh, -T, I guess. Can I just do local? No such file or directory. What? Okay, what is this thing doing, dude? You know what? I think I'm gonna call it. I'm too tired. My brain hurts. So let's go through what we learned today. So we learned that you can actually dump the Chromium master key even beyond 127 used by directly communicating with the elevated service via COM. And long as you can get around with path validation, presumably using injection, you should be able to get the key from there. And we were able to get the key from there, but we cheated a little bit by putting our POC inside the Chrome path, which requires elevation, which defeats the whole point. But theoretically, you should be able to write something that injects into regular Chrome and get the key from there. Yeah. let's see. Let me switch the input back to my computer. Okay. I'm tired, chat. Who can we raid? At this hour. I don't know who's gonna be online at this hour. Oh, Jolly's streaming. Alright. Jolly's streaming VOTV. Okay, I'll send you guys over there then. Thank you guys for stopping by. It's been a really weird stream, I know. We spent a lot of time learning stuff together, figuring out how things work, and I showcased my idiocy throughout the last 3 hours and a half as well. You're welcome. Okay, I'll see you guys later. Bye-bye.